The Anycubic i3 Mega S, a great low-cost 3D printer that's a workhorse, but it does have one slight problem. Hello everyone, Chris here. I have done hundreds of hours of prints on the Mega S, and it has worked out really well for me. There are a few things here and there that you could probably upgrade to make it even better, but for a low-cost 3D printer right out of the box, it's always done a really good job. But the biggest drawback is the noise that it makes, whether it be a bad fan or just the operating noise altogether. It's not a printer you want in the same room with you. But I definitely think it's worth spending some time on to correct some of these issues to make this printer even better, and it probably won't cost a lot of extra money. So that's what we're going to do today. We're going to take a look at the issues on the printer, we're going to address them one by one, and see if we can solve some of these problems. So let's get right into it, and we'll start by addressing that initial fan noise that you heard at the beginning of the video. So let's just start by popping the cover off the bottom and taking a look around. It's much easier if you remove this support bar. There's two screws, one on either side. No need to remove it all the way, it can just hang loose. And then there's 8 screws all around the outside of this cover to remove this panel. So with those removed, we can just slide this panel off. And be very, very careful when you're in here. You don't want to touch anything, especially over in this area where the mains voltage comes in. But I am going to go ahead and plug it back in and turn it on so we can identify where that noise is coming from. And the first issue looks to be the fan that's inside this PSU. But it does look replaceable. So let's remove that and see if we can get it fixed. Be sure to unplug the machine after you're done with this test. And wow, this thing is dusty. But that PSU is held on by these 4 screws up here in this top cover. We'll definitely have to do some cleanup on this thing before we start using it once again. Back to the underneath. Now we should be able to just lift it out. I'm going to go ahead and remove the wires, but now might be a great time to take a picture of these wires so you know how it was hooked up when you took it out. If you're not used to the standard for mains wiring on some of these printers, a lot of times you will see the hot wire be brown and the common wire be blue. And here's our PSU. These covers usually only just have a couple of screws in them. There's one right here, then one up here at the top. And then this whole thing should slide out. Now remember, if you're going to open one of these PSUs, be very careful inside here. These capacitors can hold charge for a long time, and you can get a shock even though it's not hooked up. We're just interested in this case fan right here. And it has just a regular JST connector on it, so we can remove it from the board. And this looks to be around a 60mm fan. I do have a couple of these on hand. Let's see if we can find one that's halfway quiet. I'm going to go with this fan right here. I believe this is a Cooler Guys fan, is what it's called. It is a little taller than the stock fan, but I think it will still fit in the case. Remember, this is a 12-volt PSU, so 12-volt fan. On the other side, there's just a couple of screws. And we'll swap in our new fan with the blades to the inside, so we're pushing air out. There we go. We'll go ahead and put the cover back on our PSU. Plug in our new fan. It's probably a great time to check the polarity. Make sure it's the same on both fans, the old one and the new one. This one was. And we can slide the cover back on. And we'll put our screws back in. And we're ready to hook it up and put it back in. PSU's back in. Let's fire it up. That is so much better. You can't even hear it running. That's great. So, we're already making progress. So there it is. We're done for this week. I'll see you on the next one. Nah, I'm just kidding. So, now that we have the most obvious thing fixed and the printer's quiet when we turn it on, let's start a print and see what other things we might need to fix. This might not be the only fan issue on the printer. There is a mainboard fan, a hot end fan, and a part cooling fan. So, we might find something else we need to change out. But let's just take a listen, see what it sounds like when we kick off a print. And that didn't take long at all. You can hear the main board fan spin up underneath there. It is quite loud. And the hot end fan comes on as well. which is also a pretty loud fan. It does feel like it's kicking out quite a bit of air. Let's go ahead and let it run so we can see if the part fan is adding any noise to this. Then we'll just take a look at them all at the same time. So the part fan's on now. The fan noise is just ridiculous, so I really can't tell how much it added. You could tell it kicked on, but it might not be all that loud by itself. You can hear the machine operating probably right now. Just in general, it is really loud. Stepper noise, it's a little rattly. So we have a few other things to fix other than fans. But let's go ahead and take care of the fan problem now. Back underneath, this is the fan that's causing us all the problems. It is actually triggered by G-code by the board, I'm guessing, when the print starts. Probably when the motors are energized. So we're just going to swap this one out as well. It just has a bracket that hovers over the board. We'll just take out these two screws. And it's plugged into this center set of fan pins. And this one is a 50 by 50 by 10. Again, I went with the Cooler Guys fan because they got really good reviews. And after hearing the one that went in the PSU, hopefully this one is just as quiet. So it should be a direct swap out. Remember to check your polarity. This one is correct for this board, so we're good there. We'll just plug it in, and we'll screw it back into place. The airflow is going to go down towards the board. That one's all set. Now let's check out what's going on with the hot end. So on the hot end carriage, you can take just this bottom section off. That's where the fans are. They're just screwed down to the sides. Part fan over here, hot end over here. There's a PCB inside here where they connect. So you don't have to run it all the way back to the main board. So that's nice. But we'll take off these two screws here on top. And then in back, you want to take these two out. This one and this one over here. That'll get that cover off. Then you can pull that cover. And let's just unplug them both. There is a little bit of hot glue on here. You might have to peel that to be able to get those plugs out. Hot end fan is the right one. Part fan is the one in the center. Now we can remove the whole thing. So on this side, we have one of these slim fans. It's a lot like an Ender 3 fan. It might be a little thicker than that. I think they're 30mm blower type. That's the part fan. I'm going to leave that in place for now. I don't think that's hurting us too bad. It's this one right here, the hot end fan. It's a 40mm, 40-40-10. This is the one that's causing all the noise. So I'm going to swap that one out. And it just has screws with nuts on the back holding it on. Here's the old fan. Do note they use this smaller type of JST connector. These are the ones with the pins that are 2mm apart. They're a lot smaller than the ones that are on the board side. So you could either cut this off, use that connector, solder it together, or if you have some of these, you can go ahead and replace it on your new fan. That's up to you. I just clipped and spliced the connector to save some time. Again, you can put a new one on if you want, if you have one around. I don't carry these usually just the bigger ones that I have on hand. But the fan we're going with is a sun-on fan. It is a 12-volt fan and it is 0.72 watts. This fan is pretty quiet, but it does have a pretty good output, so it should be more than enough to handle that hot end and reduce the noise of the printer. So we'll just put it back in the shroud. Note there are some nylon washers to keep those fan blades away from this vent. We want all the air to push towards the hot end, so the fan will install just like this with the sticker up. Now we can plug the fans back in, and we'll put our shroud back on. Make sure your wires are routed correctly. You don't want any of those getting close to the hot end. Now that we should have most of the fan issues taken care of, let's go ahead and start another print and just judge how loud the printer is now. The board fan already started. You can barely hear it running. You do have the PSU fan and that board fan running at the same time, but it's so much quieter than it was before. On these, the hot end fan doesn't start until the printer gets to 60C, which is nice because it's not running all the time. So the hot end fan is on now. It's a little loud, but a lot quieter than stock. The stock fan was actually starting to give out a bit, so you could hear that when it first started. It would kind of level out eventually. But the sun-on fan is going to be a lot higher quality. It'll last a lot longer. So even with just the fans running, the printer is still fairly loud. But take a look at when the print actually starts. We definitely have some work to do here. And just for reference, this is full blast with the part fan on. It really doesn't make a whole lot of difference. So there's the fan upgrade, and I'm not super happy with this hot end fan. It is still just a little bit loud, but I don't want to use a quieter fan because it might not put out enough air to cool that hot end. You might cause some heat creep. But the hot end fan isn't on all the time on this printer, only when it's printing, so it's not going to be sitting somewhere running constantly. So I can definitely live with that. Now, this machine is pretty noisy in general, mechanically, and there's a lot of little tweaks you can do to quiet it down, but the best way to resolve stepper noise is to upgrade your stepper drivers. And there's a lot of great silent ones out there, especially the ones from Trinamic. Today we're going to take a look at some TMC 2208s, and there's a few reasons why I went with the 2208 than some of the other models, and that's what we're going to check out now. So here's the board we're dealing with here. This is a Tri-Gorilla 1.1. Anycubic uses these a lot in a lot of their printers. They're fair boards, they have a lot of extra pins. It is a 2560 8-bit processor, but that's usually just fine for an i3 machine. You do have 5 drivers, because this printer, it actually levels the X gantry by using 2 Z motors. So they control one with the Z and one with the E1, where the first extruder would be. Now, I'm not interested in flashing the firmware on this machine, but I do want to change out the drivers to those 2208s. And because I don't want to edit the firmware, there's a couple things we're going to have to do. Let's take a look at the drivers first, then we'll come back to this board. These are both Big Tree Tech 2208 drivers, but there's 2 different styles of this driver that you can get. One is in the step direction mode, or standalone. The other is in UART mode, where you can use the software to control all the attributes. Since we don't have UART connections, you do have some on this board. You could jumper them over, but then you'd have to flash the firmware to control them. I wanted some that were in standalone mode, and you can move some solder pins around on these to configure them however you want, but that takes a real skill in my opinion, because those are really small pins. So the step direction version is available, so they come pre-soldered the way they should to be in standalone mode. And it's all about these 3 solder pads right here. These decide what UART pin you're using. You can see these 2 are soldered. That's the lower pin. This is a UART driver. On the standalone driver, those 3 pins are all open. There's no UART pin in play. So that won't confuse the board. You can run these as is and use the trim pot on top to set your current. And just so you know what to look for if you want to get some of these standalone, they'll be marked as step/dir. The UART one just says UART mode. So get the ones that are soldered correctly, save yourself a lot of headache trying to solder those really small pins. So now we have the drivers we're going to use. I'm going to go ahead and pull this fan off because it is really close to the top of the drivers, and show you what's underneath each one of those. These are all A4988s. They're kind of noisy and they can leave artifacts in your print quality. So it's always a good idea to swap these out to something newer like a TMC driver, like the 2208s we're going to use now. Notice where the potentiometer is on all of these. They're all facing down. We need to make sure that we install the new drivers in the correct pin orientation. So let's go ahead and pull all of these. They should just slide out. And you'll notice underneath all these drivers, there's no jumpers. On a lot of boards like this, that are set up kind of like ramps, you'll be able to set the microstepping with jumpers underneath here. You just remove the caps and set them accordingly. This board defaults to 16 times microstepping. You can't change it. But that does work with the 2208. However, this board is set, does work with these TMC drivers, the Big Tree Tech boards, to set it to 16 times. So it's not a big issue for us, but just be aware that you can't control that on this board. The next hurdle we have to jump over is how these motors are cabled. The 2208 is going to run in the opposite direction as that A4988. And you can, again, adjust that in the firmware, but we're not flashing firmware today. So your best option is to flip the cable over. And it's relatively easy to do. You can remove the motor cable, These caps for the clips, they do slide off pretty easily. I usually just work them loose with a flat blade screwdriver on the bottom, a little bit at a time, do one side then the other until it kind of wiggles loose, and then I just flip it 180. You can put it back on, put your motor cable back in, and now your motor will be turning in the opposite direction, so that'll be correct for the 2208. And I'll just do all the rest of these, because we're going to do all 5 drivers. So all of our motor cables have been flipped over, so it'll run in the right direction. You might want to go ahead and take this fan bracket off. There's just 2 screws on the top side here, and you can pull that bracket. Now we need to install the drivers, but you need to make sure that you get it in the correct orientation. If you get it flipped over, it could ruin the driver or the board. The badging on the board is pretty good, so you can line up the pins, but it's just as easy to take a look at the A4988. So here's the A4988, and the potentiometer was in the down position. So if you flip it over, here are the pins. I always look for direction and ground. So compare that to your Big Tree Tech driver. You can see on the top of this driver, you have direction and ground. So it will be the exact opposite. So direct and ground are down. So the potentiometer on the A4988 was down. On your new driver, it's going to be up. So we'll install all of those just like that. And they just slide into the same pins, just like the A4988 did. Just like that. And we'll put all 5 in. All the drivers are in. We need to put on some heat sinks, but that's one thing to note. The ones that the Big Tree Tech drivers come with, they're pretty tall, and they just barely clear this fan. So you might want to print a different fan mount bracket, or at least put some washers underneath here to raise it up just a bit, but it does just clear. It'll set in there just fine, but you might want to back it off that heatsink just a little bit. So be aware of that, or you could use a lower profile heatsink if you wanted to. They should still dissipate enough heat for these 2208s. They should work just fine. So just keep that in mind. I'm going to go ahead and put all the rest of the heat sinks on. Then we're going to have to adjust the current on the drivers. So now we're powered up. We want to check the current setting on all these drivers. And you do that by measuring the reference voltage. So you want to use your multimeter and find a ground. I just use the ground coming in to the printer. And for these drivers, there is a reference point that you can check. There's a spot that you can put a pin. It's the top one to the left from my orientation. This one right here. This will give you the correct reference voltage. You can see on my meter, I'm setting just a little bit over 800, and that's usually where I start. I usually set them all to 800. If the motors are getting too hot, I'll turn them down, or if they're too loud. If you're seeing shift layers, I turn them up a bit. But I usually start around 800 on most drivers. And to adjust that in standalone mode, you set it with this potentiometer right here. It's probably a good idea to use something like a ceramic screwdriver so you don't short anything out. Just be really careful. There's really no rhyme to reason as to which direction increases or decreases that reference voltage to adjust the current. You're just going to have to play with it a bit. On these, turning it to the right actually lowers it. Turning it to the left brings it up. So very small adjustments, recheck with your meter, and then do that for all the drivers. Again, I'm going to set all of them to 800 for now. The drivers are all in. All of them have been adjusted with that trim pot to 0.8 of a volt. That's a good reference voltage to start. Now we can go ahead and put our fan back on. It will probably ride just on top of those drivers, but that should be okay. And now we're ready to put everything back together and start another test print to see if we've improved anything. And here's it printing after the driver change. It has quieted down the motor noise a lot. And again, it should improve print quality. So we're doing pretty good. The printer's a lot quieter. We've probably got a lot more efficient fans now. And the new drivers should improve print quality, and they've reduced the motor noise greatly. But there's one more thing that's always bothered me on this printer. And that's the fact that when you level this bed, you almost completely compress all of these springs, and I never really cared for these bed knobs. So I definitely want to swap out the spring. And there's a lot of great STL files for bed knobs out there. I got these off of My Mini Factory. These were created by Mark McCary. I will leave a link to these, but these press fit really nice on the existing knob. You might want to put just a little bit of glue on there, but they're actually pretty snug without it. So I'm just going to spin all of these wheels off. You can go ahead and remove these clips if you like. They are screwed down from the bottom, but you probably don't need to. So let's go ahead and remove the bed. Now is a great time to do any maintenance you want to do. Clean this up just a little bit. I definitely need to remove some dust on mine. And then I'm just going to swap all these bed springs out for these yellow springs that I put on a lot of printers. They're affordable, they're available pretty much everywhere, and they're nice and stiff. They'll hold up to a little higher temperature as well. You shouldn't even have to change this screw. You should be able to use the stock hardware. All the new springs are on. I've got my new knobs on there. The spring is still compressed quite a bit, but it should make the bed a lot more firm. And if the nozzle is too close to the bed after that, there are adjustments on the back of the printer for both Z end stops. You can adjust these two screws right here. Just turn them down a bit so it triggers the end stop earlier and you won't collide with the bed. So now we'll go ahead and level up the bed, and we need to do a test print. And here he is. This is Hellboy from Wexter. Veteran did a great job on this. He always has a lot of cool characters. It's out on my mini factory. I'll leave a link. But the print turned out pretty darn good. This is red glitter. I believe it's blood red glitter from Printed Solid. This is Jesse PLA. So the printer's turning out some pretty nice prints. So there we go. Our Anycubic i3 Mega S upgrade is complete. The new drivers are going to help out a lot. They definitely made the whole thing a lot quieter, as well as the fan replacement. And the cost wasn't all that much. The drivers were around $25 for the set, and the fans were around $5 to $6 each. So definitely a worthwhile upgrade, and now I can start using this printer again because it's quiet enough for me to run it while I'm trying to work down here in the basement. So that's it for today. Hopefully you found this interesting, and I'll see you really soon on the next one.